Do you understand?
So a few.
Yeah, I'll just try to just summarize what I understood and see if it really makes sense.
Mhm.
So Yang is like the data model. It doesn't have any data. But if you want to, if you have a system that is using the model, it will send the data to different machines using the XML formats.
Mhm.
And if you want to have JSON or YAML, you have to convert that XML format into JSON or YAML.
Correct.
Yeah. Okay.
Yeah, and I mean, if we have time, I don't know what everybody's schedules look like. And there's actually, I actually think, so I sent this to you as well, or you had commented on something that was on social, or no, it was in one of the Teams rooms. I'm sorry. There's been a few presentations by Hank Preston and Brian Byrne around using Python and NC client to send data to a netconf data to a device, but you define it in YAML format. So we can convert, because all of this is structured, and all we need to do is worry about where the keys and values get placed. So there's libraries that you can use to convert from JSON to XML, from YAML to JSON, YAML to XML. So there's a way that you can take YAML data and have it fill in to specific tags in XML using Jinja templates, and then send that to a device using NC client to configure it via netconf. And I've got a demo that I put together for another. I can't do the demo, but I can walk through that explanation if we have time and there's interest. But yes, Judith, your understanding is correct. Yang creates the model. We send data to that model. If we're doing it via netconf, it must be over SSH and using XML. There's no other way around it. If we're doing RESTconf, which RESTconf is just a RESTful API, it's not fully REST, it's RESTful or REST-like, that it connects to that model. We can send either JSON or XML encoded data to a specific RESTconf URI, which is basically that same path. That same pathing that we saw with the XPath there. We can send either data format to the RESTconf URIs, XML or JSON. YAML, you'd have to do some conversion. There's no native handling of YAML data against a RESTconf URI. But yes, your understanding is absolutely correct. So a few notes on Yang and NSO. Now, Yang is the language that we use to develop the models, and you'll hear a couple of different formats of models. So if we talk about individual devices, you'll hear native models that are designed by the vendor. You'll hear OpenConfig, which is kind of an IETF. You have OpenConfig, which is basically a Google-funded consortium to try and standardize configuration across multiple vendors of devices. It's kind of a nirvana state. We'd want everybody to go OpenConfig, but it's never going to happen. And you also see IETF models, which are the standards-based standards body-based models that some devices support in some way, shape, or form. Native models will obviously have full coverage because they're defined by the vendor, but even then you're going to get gaps in coverage, especially like I spent a lot of time in the data center space early, like 9.2 code, we started introducing Yang data models, was very rough. 9.25, 9.26, 9.27 are much better in terms of Yang coverage for that configuration against the device. So it's still not a one-to-one yet on some devices. Things that are designed with models at the very front of it, like the Catalyst 9000s, Catalyst 8000s, those are all model driven from the very start because they don't have to deal with all the baggage of previous code versions. So you hear different types of Yang models is a way of saying that. Now, just because a device does or does not have Yang models does not mean that we can or cannot use it with NSO. Again, we have that parser logic within NSO. NSO uses Yang models in as much as that's how we define our services. And I'll touch more on what a service is, but we don't have to worry about a vendor created model with NSO. We create our own Yang model in NSO that gives us the care bus that we want for our configuration against the network or that individual device. So we don't need specific models with NSO. NSO creates its own, or we write our own models for NSO based on how we want to configure that device. So that's why Yang is important with NSO, because let me take a step back. That is why Yang is even more critical and important to NSO, because you have to understand Yang to write the automations with NSO.
And hey, can I throw something?
Yeah.
I was just going to kind of expand on what you were saying, that so Yang is how NSO is storing it. But if some new manufacturer comes on the market, you just need to figure out, how to talk to that and how to translate the data from your Yang model to talk to that manufacturer. So it's kind of the way it's structured. It's easy to add other things to it.
Yes and no. I mean, so the idea, everything inside of the the NSO CDB is a Yang backed data store, which allows us to expose netconf and restconf things northbound. If a device supports Yang, and of course it's Saturday, so I apologize if you hear dogs barking. I have a noise cancellation system, but you'll probably hear my voice go weird here. If a vendor has native Yang model support for a device, say Juniper. In fact, the Juniper NED for NSO does not use CLI. It uses netconf natively. That makes the operational interlock between NSO and the vendor's device easier because they speak native netconf, and we can import and we can make a NED very quickly. It still doesn't solve the problem of having to write a Yang model for your service, because that's all bespoke. Now, the NED does the heavy lifting of, okay, I've got this data, now I need to translate it in a format that the end device can understand. And those NEDs are discrete packages that are installed, purchased and installed based on your needs. You don't get all of them all at once. But once you have that NED, you don't need to change anything in your Yang model that you've written for that service. So I've got some examples of just something simple like I think it's NTP servers, creating NTP servers and applying them towards iOS devices. And I'm doing it against Cisco iOS. But to move to iOS XR, it's fairly trivial to do. I just need to build a new template and have new data that fills in that template, and then the NED figures out everything else. So, and I'll walk through that process there. But having netconf enabled devices definitely speeds the development of individual NEDs for those devices by our business unit, and it provides a little bit more operational assurance from a configuration standpoint, because netconf has the features of data store and candidate data store, and you can revert between the two, whereas something like SSH, you have to send the configuration and then verify that it was sent appropriately. So there's a little bit more hand waving when we do SSH configurations versus netconf at the back end. But again, that's pretty deep into the NSO weeds there. So I'll back us up just a little bit. And we'll get into the NSO architecture itself, because I've talked a lot about it. So at its core, this is NSO. There's a lot of stuff going on here. So at the bottom, we have our networks that we're going to be configuring. And then we have the device abstraction. So you see that there, those are the NEDs. We have iOS, Junos, EOS, and other NEDs that are there. That's what allows NSO itself to connect to those multi-domain networks. Over on the right-hand side there, you'll see ESC. That's the Elastic Services Controller. You can use NSO as a full etc mono NFV management system for large-scale VNFs. So for those in the Cisco space, if you've heard of things like SAE or Services Aware Edge, you're looking at orchestrating large virtual compute pools for maybe you're a service provider, and rather than having to give everybody a firewall and a load balance and everything else, you're just establishing that through VNFs, through virtual network elements. The ESC portion, along with the NFVO, the Network Function Virtualization Orchestrator, can perform those etc mono NFV architecture functions. So you can use it as a way to control all of the virtualized pieces. So that's your VNF manager, that is your ensuring service compliance, that's ensuring proper state of the VNFs. There's a whole other piece of things that comes behind managing VNFs at scale that comes in, can be included as part of NSO. In the middle there, you'll see the service manager and device manager and the package manager, and that's all surrounding the CDB. The CDB is the configuration database. I've got another slide on that in a second. The service manager is what applies services and manages the lifecycle of those services towards the device. A service, don't think of a service like Radius or TACAX or DHCP that the network provides for you. In NSO, a service is a set of configurations that applies to one or more devices, and I want to track the state of that. So if we think about turning up a new wireless SSID in an enterprise network, maybe it's a guest SSID. We have individual touch points along the network that we need to configure. We have the individual wireless controller. We have the switch ports that maybe that wireless controller may be changing or being attached to. We may have a firewall that we have because we're doing guest network. We want to make sure that those services are firewalled off. We may have one or more routers that may be controlling VRS for further segmentation. So if I wanted to define this wireless SSID service, normally if I was to do this device by device, I would have to say, I want to turn up a guest SSID. I have the business intent and it's all locked in my head. I translate that business intent to wireless controller configs, to switch port configs, to firewall configs, to router configs. I have to do all that by hand, and then I have to make sure at the very end of the day, everything's going to work and be applied correctly in the right order. A service in NSO, I build via a Yang model what I want that service to look like. What do I care about? What are the keywords that I want the CLI to appear in? Then I build a service package which includes an XML template along with any Pythonic or maybe Java or even Erlang logic for programmatic constructs. And then I load that as a service in NSO. So if I say guest SSID, maybe I've got 2 or 3 things that I care about as part of that. Maybe it's a subnet, maybe it's a guest SSID name, and everything else I don't care about. I can build in my template, say, well, I care about the name and the IP space and whatever else, and I'm going to auto provision everything else along that service, and I'm going to apply it to the individual devices that I care about. So it's doing that entire chain of configuration across all those devices, across multiple domains in one commit action. Now, the important part about the service manager isn't just I want to apply the service. I need to make sure that I have the service, I can do any update and read operations and delete the service at the end of that. So the service manager handles that piece. The device manager just handles the individual connections to the devices through the NEDs. And the package manager handles the packages that make up the service. Everything ties into the CDB, and then because of how NSO is designed, we have a variety of different ways to interact with it. We have a CLI and we have a web UI, but it's also programmatic, so we can work with Java, Python, and Erlang as actual things inside of the NSO architecture itself. So I can invoke via the CLI some logic that's controlled via Python through a service. Then at the very end, you see under ops and provisioning, I have netconf and restconf. So everything in the configuration database is backed by a Yang data store, which means I get all of the benefits of that come with Yang, so netconf and restconf, exposed automatically northbound of NSO. So now I can integrate other things, maybe self-service workflows through ServiceNow. Maybe it's CI/CD pipelines through some kind of CI like GitLab CI or GitHub Actions or Bitbucket or GOGS or whatever else. I can expose those northbound and communicate via NSO via those northbound APIs. So it's really this complete system that's meant to integrate. I mean, this came from service provider space, so it's meant to integrate into an OSS BSS from an SP, but now you get that same level of flexibility in the enterprise or whatever other space that you're working in. So a lot to take in there. So I will pause as we move to the next slide. If there's any questions about any work covered.
Hi, Quinn. This is Abdel. Sorry for I joined a little bit later. Would you mind if you can go back to slide to the previous slide?
Sure.
My last experience with the NSO, ESC was a separate product that actually integrated, and it's part of it can be integrated and then can be used to instantiate containers and virtual machines. I was wondering if it's prepackaged within the NSO, or is it something?
It's an add-on. So you don't get the ESC by buying NSO. You still have to buy. I mean, it's an integrated feature. It's integrated in as much as it's not like a separate thing that is you have to instantiate all the infrastructure for. It's still an add-on that you have to pay for and apply to NSO, but it has the controller built in there. Yeah, it's not packaged. I know this is a little bit of it looks like everything's all together, but that is a separate licensed item.
Understandable. I just wanted to maybe it looked to that it was. But thank you. Thanks for clarifying. Appreciate it.
No worries.
Hey, Quinn, I have a question about assurance. It seems like
Sure.
assurance is a big part of this, for obvious reasons, right? But you mentioned that there is a whole bunch of things under the hood. So I was wondering if you can talk a little bit about what is that mechanism of assurance?
Yeah, so it's important to define assurance as it relates to NSO. So for those who are familiar with something like DNA Center, it has its own version of assurance, and that's really end user experience assurance. That's, do I have a quality of experience for my end users either via wired or wireless ports? When I refer to assurance that pertains to NSO, I'm talking about configuration level assurance. So because, just like I was talking about earlier, because NSO has, netconf and Yang has the concept of data stores and candidate data stores and being able to apply configuration, if I try to send invalid configuration towards, okay, let me take a step back. If I have a device that speaks netconf natively and I send a configuration via netconf with an XML payload towards that device, but either the namespace or maybe I'm missing tags or the name of one of those tags is wrong, netconf will not allow me to apply that configuration towards the device. It'll just say invalid, and if I use NC client, it'll spit back some errors and say, we can't do anything. We're not applying this configuration. It's wrong. Figure it out. Because NSO is fundamentally netconf and Yang under its hood, when I design the configuration of that service, and I do it using netconf principles, Yang principles, building a Yang model and having an XML template associated to that to apply the configuration, I know that when I apply that, it's going to work as long as the NED supports it. So therefore, I know that when I apply a configuration via NSO towards a device, if something is invalid, it won't work. So I've guaranteed the configuration assurance, which is different than the end user experience assurance. So that's kind of what I mean by that. Does that answer your question?
It does. I actually think it's pretty cool.
Okay. Yeah, and that's the beautiful thing of using NSO even just as your own, just a single source of truth. People have jump boxes where they SSH to all these different devices. You can have NSO do the same thing. You can use NSO as your single configuration platform using nothing but the CLI to apply configuration towards an end device. And you get a bunch of things for free, like configuration rollback, snapshotting, device sync, and all these other things that come with it. So even if you don't design any services, even if you just use NSO to configure that end device, you still get a lot of benefits out of using that.
So I have a question on that. So when you say
Sure.
applying a config, it will not work, does it mean that when you use NSO, you are just testing if this config is right? Or
No, I'm actually sending configurations with NSO. So NSO has a two-stage commit. So if you're familiar with things like Junos or iOS XR, we know that I write a configuration and it sits kind of in this scratch pad, this place this ether. Nothing is applied to the device until I hit commit. Same thing with NSO. So I can build all these configurations that I want to, and then when I do a commit action, it will commit it to the CDB, the configuration database in NSO, and then send that configuration out to all the end devices that I'm changing. So it's actually applying configuration, but because NSO has the netconf Yang stuff built into the hood, it knows if that configuration will be supported or not.
okay. So is there any way that NSO can help in case the configuration doesn't go well? Because even in XR, we have a situation where somebody did no BGP and it shut down the network. So can NSO also help in those cases where you can roll back quickly?
It does, and I'll demo that. So everything, and I haven't touched on this. I think I was going to cover it in the next couple of slides. As soon as I onboard a device into NSO, I take a snapshot of that device's state. So I have the complete running configuration of that device from the time it enters the NSO device manager, and that is archived in the CDB. If I make a change on the device natively, so I can SSH to the device, make a change, I can compare what exists in the CDB versus what's on the device. and see what has changed. Do I want to, and then make a decision. Do I want to sync the device config to NSO, or do I want to say, no, they did the wrong thing. I want to sync NSO back to the device. So it becomes your single source of configuration truth there. More importantly, if I configure something through NSO natively, well, in the case of if I want to sync the router's config back into NSO, it takes another snapshot. But I have a complete log of every single snapshot of that device in the entire CDB since it was brought on into NSO's device manager. Now, if I configure something through NSO, say I did a no BGP on a router and it broke something, as long as I have reachability back to that router, I can do commit rollback and apply the previous configuration, which rolls back the configuration applied back to that device. And then it will take a new snapshot. So I have a complete record of I had BGP, I lost BGP, then I regained BGP by the rollback. And it takes all those snapshots. So I have a complete, almost a Git log. If you're familiar with Git and GitHub, it's almost like a Git log of every change on the network that's occurred because of that device being in the device manager.
Okay, thank you.
So moving into this slide, and this is really a snapshot of some of the NEDs. We have over 100 supported NEDs, 100 supported vendors, devices, et cetera, supported in NSO. So there's again, the NEDs are you pay for them. Obviously, they don't all come in the single box, but you can customize this network or the NSO to how you see fit. So if I have, if I'm a service provider and I'm running Arista and Juniper and I've got A10 firewalls and I've got some Sienna optical gear and I run a Cisco core, I can buy those NEDs to support all those devices natively inside of NSO. So you can really pick and choose and how you're building all this. But they're all support, all these are supported. We're constantly releasing new ones. And not only that, they're always being updated. We know that iOS it isn't static. None of these things are static. So as new features get added, those NEDs are then updated as well to support newer features and things like that. So getting back to the CDB here, and that's the piece that I really want to highlight. It's built for speed at scale because it's just native Yang schemas with netconfig, restconfig things exposed northbound. So everything is being mapped inside of that CDB with a Yang model, and then we've got that configuration data via XML or XPath. That's why this whole thing kind of comes together and is very optimized for speed because it's all natively operating on the model. We can make it highly available. So, normally we have, in like the sandbox, the DevNet sandbox, we just have a single NSO instance, but you can make it highly redundable, one for hot standbys. You can, everything is running in memory, so it's blazingly fast that way. So you obviously have to scale these things appropriately. The other nice thing about it is just like any other normal database, we have the concept of lock and unlock. So if I'm performing a commit action with a service, that database is locked for all other changes until that service completes successfully, which can be a good thing because then we have the idea of concurrency, or we prevent the need to have to worry about concurrency, I should say, where multiple people are making changes at the same time. If someone gets in and locks the database, well, you can't do any changes, so we don't have to worry about how we mitigate those issues. But for the use cases that I'll talk about, it's not a big deal. But as we start designing complex services, especially geographically diverse complex services, with lots of Python logic or something like that, you have to be wary that any time that this service takes to run and complete is locking the database for other people. So if I have a service that takes 45 minutes to make a change, that database is locked for 45 minutes and no one is able to do anything else with there. Could be a big deal, could not. You have to, but those are things that you have to worry about as you start developing these things at scale. So I touched on the ways that we can work with NSO. You can do it through CLI. So there's two flavors of CLI. There is a Junos style CLI. So Derek, there's your foray back into Junos CLI there. But even if you're working in Juno CLI, you can still configure Cisco devices or Arista or whatever else. It's completely multi-platform. It's just how you choose to operate with there and what you feel comfortable with. Me being a Cisco guy for the past 15 years, I use the Cisco CLI because it's what makes sense to me. So all the configuration syntax, if you're using the Cisco CLI, is just like being on a router. There are a few other, it's not like we just go right into conft and provide configurations. There's a different path that we use to get there. But once you get into the configuration of the device, it looks just the same as a CLI. There's strict separation between operational and configuration level data, which seems kind of like why do we really care about that? But it becomes important because configs are separate, but we can still use and access the operational data that exists within NSO, depending on how the net supports it, through a separate set of channels there. So we're not blending the two. We can do the standard range and group operations we're used to inside of iOS. We can do full AAA integration, so not only do the devices themselves have the AAA and integrate into NSO, but we can also have the integrations for strict RBAC, role-based access control within NSO itself. So you may have people who are maybe operations folks that can only access these set of services or these sets of CLIs. And we've got some network engineers that can do more, and we have architects or service designers that get a full range of these things. So we have full RBAC inside of NSO itself. And like I touched on earlier, there's a two-stage commit engine. So it's very similar to iOS XR. We perform all our configurations, and then we commit, and we get an all or nothing. If anything fails, the configuration is not applied anywhere. And that includes both on an individual device level and the service level. The one thing I will also say here that's neat about even just working on the CLI interface, I came from an SP background, and things like VRFs, no matter how many times I work with them, always got me. You create the VRFs, RDs, RTs, import, export statements, address family operations, and then you go to assign some kind of maybe it's a tag subif or whatever to a VRF. Well, I would apply an IP address and I'd be, I got to apply this to a VRF, and then I would wipe out my IP address and I'd have to start all over again. NSO knows, because of the fast map construct, how the CLIs are generated. It knows to apply these things in the correct order. So even if I commit to or write to the CLI IP address, then VRF, when I do the two-stage commit, it will apply the VRF before the IP address statement on that interface to make sure it applies in the correct order. So it has this a priori knowledge of how to apply those configurations based on how the net's designed and the parser logic to make sure that configuration is applied no matter how it's entered in the CLI. Likewise for rollbacks and things like that. Now, there are some weird corner cases, but they're mostly few and far between for pretty standard set of operations. And the other thing to touch on here is as we start moving past the CLI, the APIs are just clients of the same Yang back data store. So just in the similar way, if you're familiar, if we've worked with a device that does netconf or restconf, and you're used to working with those APIs, you realize that you realize that you're just working with the data being sent towards that Yang model on that device. Same thing with NSO. Everything that you do via an API is interacting with that same Yang back data store. In fact, the CLI is interacting with the Yang back data store, just doing so transparently. A lot of customers will start just working with the CLI because that's where they feel comfortable, but then they'll slowly transition to how can I extend this operation northbound of my network without having to give people access directly to that CLI. More importantly, we talk about things like CI/CD pipelines. I had a demo at the internal sales conference that we have every year, working with NSO, a CI/CD pipeline, and a VXLAN fabric. So we were making changes via an Ansible playbook being pushed up to a Git CI server that would then perform some runners, send some configurations to NSO via a RESTconf URI, and apply that service towards those devices, those NXOS devices running in that VXLAN fabric. So you can use those APIs to extend the reach of the network. People can be consumers of the services that you design, but they don't necessarily have to have access to NSO. So it gives you that, again, there's that API eyes in the network. Once something's in once something is in the CDB, I can expose that via RESTconf or NetConf externally, and now I've expanded the reach and I've created that API gateway for those non-API enabled devices. couple of things here. I know.
Do you